A component has failed. The flight crew knows it, the regulator knows it, and yet the aircraft legally departs. Now, you might be thinking this is some kind of schedule-saving waiver granted at the gate just to protect a timeline. Absolutely not. This exact condition was deliberately planned and rigorously analyzed during the aircraft's initial certification. It is a strictly governed procedure that allows an aircraft to operate safely, even with specific inoperative equipment. To understand the engineering logic behind this, and really what keeps us all safe at 30,000 feet, we have to look at the regulatory baseline. It's Part 25-1309. This rule literally requires the design to tolerate failures. Engineers have to assume that components are going to break, so they must design the overall system to safely absorb those individual losses. This engineering philosophy relies heavily on parallel channels running side by side. But in aerospace design, redundancy is never just a generic safety margin tacked on as an afterthought. Redundancy is mathematically sized. It is specifically calculated to absorb very precise failure conditions and keep core functions running smoothly. So, when one channel of a redundant system goes down, the architecture adapts, the flow shifts, and the remaining channel steps up to carry the load. The critical point here is that even with one channel completely down, the remaining system still hits the stringent failure probability targets required for flight. That engineered margin is the only reason dispatch relief exists at all. So how is this relief managed legally? It starts with the Master Minimum Equipment List, or the MMEL. The manufacturer writes this document for an entire aircraft type, and it's approved by the FAA. But an aircraft at the gate cannot legally dispatch using that overarching MMEL directly. Instead, the individual operator writes their own minimum equipment list, the MEL. This operational document is derived directly from the MMEL. It's approved by the operator's regulatory authority, and it is the actual document used at the gate. The legal framework that actually authorizes the use of this operator list is Part 91.213. Under this regulation, there's a cardinal rule. An operator's MEL may never be less restrictive than the manufacturer's MMEL. An operator absolutely has the authority to make their list more restrictive to fit their unique operating environment, but they can strictly never loosen the constraints established by the original certification. The relief granted by this list is never a free pass. It is strictly conditional. Listed items carry mandatory provisos that dictate specific required actions. Take an O proviso, for example. This mandates an operational requirement. It means the flight crew is legally obligated to execute specific, alternative operational procedures to safely manage the aircraft with that degraded equipment. Working seamlessly with those operational limits, the list also often mandates an M proviso. This sets a strict requirement for maintenance procedures that absolutely must be completed before dispatch is authorized. Maintenance personnel are required to physically secure, isolate, or deactivate the failed component, ensuring it cannot interfere with operative systems while in the air. Once that maintenance action is wrapped up, the affected control is physically placarded on the flight deck interface. A highly visible marker is placed directly over the degraded unit, ensuring the flight crew constantly and visually acknowledges the system's degraded state. This eliminates any ambiguity whatsoever about which systems have been intentionally isolated. Crucially, this dispatch relief is not open-ended. Repair categories strictly bound the relief in time. Each category establishes a hard limit on exactly how long a specific item can stay inoperative before the aircraft is legally grounded. Among these, Category A bounds a highly specific time frame that cannot be extended under any circumstances. When that clock runs out, the aircraft is grounded until it's repaired. Underlying this entire framework is one fundamental exclusionary principle. The rule leaves absolutely no room for interpretation here. Anything not named in the minimum equipment list must be operative. The list exclusively dictates what is allowed to be broken. Which brings us to a definitive conclusion about the system's architecture. If a component fails and it is not on that approved list, authorization to dispatch is immediately and completely severed, regardless of how minor or inconsequential the broken part might appear to be.